Okay, students, in today's class, we will be doing composition of functions. So let us understand the definition. For doing this, you need three sets, A, B, and C. This is A, B, and C, which are not necessarily distinct. That means need not be different sets. It can be same set also. 3 times you have to take. And the functions are defined like this. F is a function between A and B. F is a function between A and B. G is a function between B and C. G is a function between B and C. And this is A. The composition, or it is also called as a product. Composition or product of these two functions is defined as the function G composition F. G composition F is defined as a function from A to C. So this is called G composition F. There is a function between F between A to B, G between B to C. Then if you are trying to find out a product between the first set and the last set, is denoted with G composition F. Look at that, G comes first. You will have to write G first, then followed by F in this notation. G composition F is a product or composition between two functions, and it is defined between which set to which set? A set to C, with following definition. That is, G composition F can be written as G composition F of any element is defined as, you need to first apply F for A. After applying F, whatever element you get, for that you should apply G. So for every element of A, you need to do this. And the pictorial representation is here. For a function F from A to A itself is defined as F composition F itself. So since it is a product, you can also write that F square. And F into or F product F square becomes F cube, and so on. You can also do this n times, so it becomes F to the power of n is a function defined between A to A itself, which is called as recursively defined. For getting nth function, you need to have n minus 1 function product with F itself. That is about definition. Let us move on to problem, a simple problem which I have taken here to show that. Let A is a set defined with elements called 1, 2, 3, 4. B is a set with the elements A, B, C. C is a set with the elements W, X, Y, and Z. So since we need 3 sets here, there are 3 sets here, 1, 2, 3. And F is a function from A to B, and G is a function from B to C, given by F values are here and G values are here. F is a function defined between A and B, therefore mapping is done. So 1 is having an image A, 2 is having an image A, 3 is having an image B, 4 is having image C. You can also represent this in terms of a pictorial representation. Whichever is easy for you, you can practice that. Sorry. Similarly, G is a function between B to C and B elements to C elements. So, A comma X is nothing but A is having an image X paired with X, and B is paired with Y and C is paired with Z. That is what defined for both. Now, you need to find out G composition F. So let us go with the definition of composition. So I start with G composition F for all the elements of A. For all the elements of A, first I will take 1 and check the element. According to the definition of composition, G of F of 1 I have to write. G composition F of 1 is equal to G of F of 1 as per the definition. Now, we need to find what is this F of 1 in the function F. So, 1 is an element under the function F, and to which element 1 is mapped. That means image of 1 you have to find out. So, one image is 1 is paired with A, nothing but A is the image of 1. Therefore, you write A here. And it becomes G in the function G, you need to find out A element pair. What is the A element pair? X. G of X. G of A is nothing but X. The answer is X. So for this, answer is X. In the similar way, you need to write for all the elements. G composition F of 2. Go to second element. As per the definition, it becomes F of 2. What is F of 2? F of 2 is in function. Thus, you need to find out two element which got paired with A again. So, write A. G of A, I have to check here. It is X. The similar way, you need to find out for all the elements. That is G composition F of third element 3, G of F of 3, G of F of 3 is paired with B, which is equal to G of B. B is paired with Y. Answer is Y. In the similar way, you have to find out for the last element also. 4. G of F of 4 is equal to G of F of 4 here is C and G of C is Z. Answer is Z. So that is what the answer for all this. So whatever explanation I have done, it's there here, and that completes the problem 1.